Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I wanted to do a code review on a Kaggle Playground competition, Playground competition, Season 3, Episode 24. And basically, what I did was I used Jax Linear Regression to predict on this. This was a binary classification problem, but they wanted you to predict on probabilities. And if you use sklearn and you go into logistic regression and some of the other classification problems, they will have a predict proba. But on Jax, which is a made from scratch model that I made, there is no predict proba. So what you have to do is it's a regression, you have to run it up on linear regression. So even though it is a binary classification, you have to run it up on linear regression to get it to work. And I scored 83.5% on that, and the highest percentile was like 87%. So it wasn't too bad. And I've got to do some more experimentation with Jax as well, so I can use other models on this, what would be a predict proba. It's a probability. So what we'll do, without further ado, we'll go ahead and start with the code review. And this program has been written in Kaggle's Jupyter Notebook, which is a free Jupyter Notebook, and it is stored in my account. But what I will do, I will leave a link to the code in the description box down below, so you can look at the code if you want to look at the code. The problem was binary prediction of smoker status using biosignals, and the prediction was whether they were a smoker or not. But then what you had to do is you had to run it up as a regression to get the probabilities. So the problem statement is predict the probability of a smoker's status. And then what we want to do is we want to import the libraries that we're going to use for this program. We're going to import Jax, which is a library used for research, and it's made by Google. And it's supposed to take over TensorFlow. So that's why I'm studying it, because since it's supposed to take over TensorFlow, I thought it would be a really good idea to study this library. And so I make all my models and everything from scratch. I haven't used it yet, but they do have a Flax, and Flax has models in it as well, but I've not used Flax yet. And then after we've imported Jax, we're going to import Pandas, which is going to read the CSV file into the system and create data frames. We're going to import OS, which goes into the operating system and retrieves the CSV files in the program. We're going to import sklearn, which provides machine learning functionality. We're going to import matplotlib.pyplot.splt, which visualizes the data, and then we're going to import Seaborn, which also visualizes the data statistically. So after we have imported our libraries, then what we need to do is we need to retrieve the CSV files and we're going to do that from the OS library, and it'll go into the operating system and retrieve all the files from Kaggle input. And then the 3 files that it retrieved were train.csv, test.csv, and sample submission.csv. There are, I think, maximum of 24 columns of data, and so I want to be able to see all of those columns of data, so I set it up for pd.setOption display.maxColumns none, and that enables me to see all of the columns of data. And then we're going to read the CSV files. We're going to read the train equals pd.readCSV, and then the address, the link of train. We'll do the same with test, and then the same with submission. We're going to be using sample submission. So you look at train here, and it has 24 columns of data, 159,256 examples, and it gives you all this information about the person's body, and it tells you whether they smoke or not. I checked in info, and info is all of the columns of data are either a float or an integer, so that's good because that means that I don't have to encode any of the columns of data. We check for null values. We don't have any null values, and that's good because that means I don't have anything to impute. We do the same for test. Test is the same format, except that it doesn't have a smoking column because your smoking column is your target. We check info of test. The info is the same as the train file, except test does not have smoking. So we check for any null values. We don't have any null values, so that's good, so I don't have anything to impute. And then we check submission. So the submission, you've got an ID and a smoking. And the thing about the smoking is because it's 0.5, that's telling you that it's a probability that they're looking for. We're going to remove the ID column. The reason why we remove the ID column is because in a pandas data frame, all of the rows of data are automatically indexed, so you don't need that. So it's train.drop ID, x equals 1, in place equals true, and we do the same thing for test as well. Now we're going to analyze train. We're going to create a histogram of the smoking column, so you can see that most of the people don't smoke, but a pretty good percentage of people do smoke as well. We're going to create a heat map of all of the columns of data, so you can see how highly correlated the columns of data are. But if I had wanted to, I could have removed the columns of data that were highly correlated. But I've just found that it doesn't necessarily improve the signal. It doesn't necessarily improve the accuracy. So I decided not to do that on this occasion. But when you have a lot of columns of data, if you want to remove the highly correlated columns of data, you can. Define the target. Target equals train.pop smoking. And now we're going to standardize the data. Train equals jnp.asArray train. Test equals jnp.asArray test. So what you're doing is you are converting train and test to Jax arrays. And this is how you standardize the data. Mean equals train.mean. std dev equals jnp.std train. train equals train minus mean over STD DEV. Test equals test minus mean over STD DEV. So that's how you do it. And I wasn't really sure. I was thinking to myself, is this the right way to do it? But if you look on sklearn, when you use the standard scalar, if it's the train, you do fit transform, and if it's the test, you do transform. So I decided to go ahead and leave it in that format because that's the way I've seen it done. So you can just check here. I'm not sure it'll be there, but let's see. Standard scalar. And then C equals X minus U over S. And they give you a sample code. So it says you fit it and then you transform it. But I just did it like that because you have fit transform, fit the data to transform it. And then you have transform, perform standardization by centering and scaling. So I wasn't really sure the best way to do it. I wasn't sure whether to make a mean and STD for both the train and the test, but I did it this way. And I suppose if I have time, I can try it again and see what happens, see if it works better if the test has a separate formula. We'll check that out and see how that goes. So this is what the data looks like when it's standardized. Now what we're going to do is we're going to define our dependent and our independent variables. So Y is your target, X is train, and X test is test. And we print the shapes of those. Now we're going to use sklearn train test split to split the X and Y data sets into training and validation sets. And you can see we printed the shapes of those as well. Now what we're going to do is we're going to define the regression model. So we're going to have two functions. One is normal equation. It's going to take in X and Y, or X train, Y train, and beta equals JNP dot dot, JNP dot LING ALG dot INV, JNP dot dot XTX, comma JNP dot dot XTY, and it's going to return the beta. And then the predict is going to take X test and beta, so it's going to return JNP dot dot X test beta. So doesn't really do much. Well, it returns the dot product. And then what we're also going to do is we're going to use the JIT. And what JIT does is JIT makes the function work more quickly. And so since it's a big data set, I thought it's a good idea to use JIT. So JIT LR equals JIT normal equation. JIT predict equals JIT predict. And then beta equals JIT LR X train Y train values. Y predictions equals JIT predict X val beta. Print Y predictions. So you've got the predictions there. Now what we're going to do, the length of time that it takes to compute the linear regression, it was 9.1 milliseconds, 230 microseconds per loop. Now what we're going to do is we're going to check the RMSE. So MSE equals JNP dot square, JNP dot subtract, YFL dot values, Y predictions dot mean, and then it gives you your MSE and then your RMSE is the square root of the MSE. So you've got an MSE of 0.41. And now what we do is we use matplotlib to plot the actual values against the predicted values. And so what we're interested in is the predicted values. Now we're going to predict on the test set. So we've got the predictions equals jet predict x test beta, and then we print our predictions. And then we find we're going to use min max scale. So min equals predictions dot min, max equals predictions dot max. Predictions equals predictions minus min over max minus min. And then so you get the predictions. And then what that does is that scales everything from a 0 to 1. We create a histogram of the predictions so you can see what the predictions are like. And so generally it's anything between 0.2 and 0.6. And then we prepare our submission. And when we prepare our submission, submission smoking equals predictions, submission.toCSV, submission.CSV index equals false, submission equals pd.readCSV, submission CSV, submission. So you can see that this is our submissions. And so for the probabilities. So that's it. That's the submissions. And then whenever I submitted my work, I got an 83%, which I was quite surprised about. So I'm going to go ahead and conclude this video because I've given you the code review. I will leave a link to the Jupyter Notebook in the description box. And then so what that will do is that will enable you to look at the code if you want to look at it. I just wanted to see if they had a way you could copy the link, and there's no way to copy the link, so I'll just give you the link that I've got. So thank you to my subscribers for subscribing to my channel and supporting it. Thank you to the people who are watching this video. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And I look forward to doing another code review for you in the future.